Okay, good morning one and all. So today now I will discuss about on components of LT switchgear. So LT is nothing but low tension switchgear. Okay, so we have low tension and high tension, but now we are discussing here low tension LT. So basically the low tension is a low voltage line and high tension is a high voltage line. So in India LT low tension supply is 400 volts for the three phase. So and connection of 230 volts is the for single phase connection. So this is the component of LT switchgear, basic concept of LT and HT, low tension and high tension. So in low tension we are using here the supply 400 volts for three phase and connection 230 volts for single phase connection. So basically here four types of components of LT switchgear. So what are the four types of LT switchgear? So here SFU, first of all, first one is nothing but SFU. So SFU, switch fuse unit, and second one miniature circuit breaker. So miniature circuit breaker MCB. MCB is nothing but miniature circuit breaker, and third one more C is added, so it is nothing but MCCB. So MCCB is nothing but molded case circuit breaker, and last one is nothing but earth leakage circuit breaker, so is nothing but ELCB. So first of all, what is the first one? First one is nothing but SFU, and the second one is nothing but MCB, miniature circuit breaker. So SFU is nothing but switch fuse unit, and third one is nothing but earth leakage circuit breaker, ELCB. Okay, so last one is nothing but MCCB. So MCCB is nothing but molded case circuit breaker. So these are the four types of components of LT switchgear. Okay, next one. So first of all, I'm taking first one, so it is nothing but SFU. So SFU is nothing but a switch fuse unit. So the switch fuse unit is nothing but the rewirable switch fuse units and are used for distributing power and protecting the electrical devices and cables from damage to fluctuations. So this fuse unit is in the commonly housed in an enclosure made using quality cast iron steel sheet. So this is nothing but SFU. So SFU is nothing but simply called as switch fuse unit. So this is the rewirable switch fuse units are used for distributing power and protecting electrical devices and cables from the damage due to fluctuations. So this fuse is basically commonly in households uses house purposes housed in an enclosure made using quality CI is cast iron steel sheet. Next here I am taking, so but it is not order wise, so the next ELCB I am taking ELCB. So ELCB is nothing but earth leakage circuit breaker. So the earth leakage circuit breaker compares phase and neutral wire currents, and the trips trips whenever there is uneven current only. So next MCCB. So MCCB, molded case circuit breaker. So MCCB, it is, so the current range is 63 amperes to 3000 amperes. So next, so but the 63,000 to 3000 amperes, so we can set the trip current. We can set the trip current from meter to MCB, then MCB, then to MCB. So this is the main purpose. So what is saying here? MCCB. MCCB is nothing but molded case circuit breaker. So the molded case circuit breaker, the range is 63 amperes to 3000 amperes. So but the 63 amperes to 3000 amperes, so we can set the trip current. So we can set the trip current from meter to MCCB, then to MCB. So next, inverse time characteristics. So inverse time characteristics here, selectivity. So the selectivity, now I'm taking here selectivity. So helps coordinate relay operations along with a distribution system. So what is that? So basically in inverse time characteristics, selectivity, time coordination, avoid nuisance trips. So avoid nuisance trips. So these three are involving in inverse time characteristics. So the three characteristics, first one selectivity, time coordination, avoid nuisance trips. So first I am taking here selectivity. The here selectivity helps coordinate relay operations along a distribution system. Along a distribution system. So time coordination, here the time coordination, it allows downstream devices to clear faults before upstream devices trip. So here time coordination, so the time coordination allows downstream devices to clear faults before upstream devices trip only. So next, avoid nuisance trips. How to avoid nuisance trips? So here the tolerate small overloads or temporary surges by delaying trips. So these are the inverse time characteristics in LT components. Next, typical inverse time current characteristic curves. Okay, so the typical inverse time current characteristics curves. So basically here three characteristics are involved. So first one is nothing but standard inverse, and second one is nothing but very inverse, and last one, that is third one, is nothing but extremely inverse. So first one here, standard inverse. So standard inverse, so here the moderate inverse slope is involving. Next, very inverse. In very inverse, stepper slope. So trips faster for higher currents. And last one, extremely inverse. So extremely inverse here, even stepper for high fault currents. So what the curve looks like? So here the curve looks like basically x-axis and y-axis. So x-axis and y-axis. So here on the x-axis taking the current, and on the y-axis operating time in seconds. So at the current just above the pickup and the relay trips after a long delay. So as current is increases, operating time is decreases sharply. Okay, so what he's saying here, as current is increases and operating time is decreases sharply or immediately. So next, contactor. So contactor, so what is this? What is this contactor? How it's work contactor? So what is the key point involved in contactor? So what it is? So contactor, an electrically controlled switch used for switching a power circuit. So what is that? An electrically controlled switch, and it is used for switching a power circuit. So it is commonly used to control electric motors, lighting, heating, and other electrical loads remotely. So basically it is commonly used in control electric motors and heating, lighting, and electrical loads. So that is the definition purpose. So but how it works? So how it works? So when a control voltage is applied to the coil or solenoid. So when a control voltage is applied to the coil, so the contactor closes its contacts, so allowing current to flows in the power circuit. When the coil is de-energized, so the contact is open, then interrupting the current. So what is the key point involved in this? So the key point here, designed to handle and high current loads repeatedly and safely. So repeatedly and safely designed to handle and high currents loads. And next to isolator. So here isolator is isolating switch. So what is the isolator, how is it works, and what is the key point involved in isolator? So first of all, see the definition. Isolator or isolating switch. So a manual switch used to ensure that an electrical circuit is completely de-energized for maintenance or safety purposes. So but how it is works? So it works, it physically disconnects the circuit from the power source. What is that? Physically disconnects the from the power source, providing a visible gap confirm the circuit is off. So what is the key point involving in isolator? So the key point, it is used only when the circuit is not under load purpose. So not intended for under load, switching under load. So what is relay? So the relay, what is relay, how it works, and what is the key point is involving in that. See, what is relay? So an electrically operated switch is used to control a circuit by a low power signal, or where multiple circuits need to be controlled by one signal. It's only one signal. So an electrically operated switch used to control a circuit by a low power signal, or where multiple circuits need to be controlled by one signal. So there are many types of relays: electromagnetic relay and solid state relay, thermal relay, etc., etc. So many types of relays. And how it is works? So relay, so one relay, how it is works, we'll see that. So when a small current energizes the coil, in a coil there is a flowing small current. So the relay changes the state of its contacts, open or closed to another circuit. So that is the operation, or how it will be works, the relay. So next, so what is the key point involved in the relay? So what is the key point here? So it is used for protection, control and automation purposes. Next, MPCB. So MPCB is nothing but molded case protective breaker. MPCB, molded case protective circuit breaker. Basically here, molded case protective circuit breaker. So MCCB is equal to molded case protective circuit breaker. Okay, so this is the MPCB. So basically here one is the mistake here. So molded case protective circuit breaker. So what is that? MPCB. What is MPCB? What is MPCB? A type of circuit breaker designed to protect electronic motors from overload, short circuit and phase failure. If any phase failure, a type of circuit breaker designed to protect electric motors from the overload, short circuit and even if it is phase failure. So how it is MPCB works? So MPCB works automatically if the trips or disconnects. So automatically trips. So when the current exceeds present limits to protect the motor and wiring. Okay. So what is the key point here? The key point, it combines overload and short circuit protection in a compact device. Okay, next, electric shock. So what is electric shock? So basically you have seen so many places and so many times, okay, in the whatever it is, so that is in households and industrial. So where we'll see that what is electric shock. So what is electric shock, what is the hazards, what are the servants depend on. Okay, so first of all, what is electric shock? So what is electric shock? So an electric shock occurs when a person body becomes a part of an electric circuit, causing current to flow through in the body. Okay, so this is nothing but electric shock. So what is that? An electric shock occurs the person, so person's body becomes the electric circuit, a part of an electric circuit, causing current flow through the body. Okay, so what are the hazards? So hazards, it can cause burns, nerve damage, and cardiac arrest, or some conditions and death also. So severity depends on amount of current and duration of exposure and path of current through the body. So basically, so these are the references. So the references here, first one, S. Singh and R.D. Singh. So electrical estimating and costing, Dhanpat Rai. So and this company 1997. So that is 1997. And the second one, so the website of IS standards. Third one, so H. Joshi Residential, Commercial and Industrial Systems. So that is MC Grahil Education in 2008. So once again I will revise that. So today the topics: components of LT switchgear and 4 types of LT switchgear: SFU, MCB, ELCB, MCCB, and one by one discuss that SFU, ELCB, MCCB, and inverse time characteristics, and typical inverse time characteristic curves, and mathematical form. So where the curves is occurs like x-axis and y-axis, and the contactor. So what is contactor and how it is works, and what are the key points are involved in the contactor. And similarly isolator. So what is isolator or isolating switch, and what is the isolator, how it is works, what are the key point involved in the isolator. And next, relay. So what is relay, how it is works, what are the key point. And next, MPCB. So MPCB is nothing but mold case protective circuit breaker. So how it is works and key point, and what is that. And so, and next, electric shock. So electric shock, so that is the electric shock. What is electric shock, hazards and severity depends on that. And next, references. Thank you.